Welcome back to my channel. This is Trisha, and today we'll be doing the part 2 video of HOTS, means high order thinking skills questions. So let's start with the fourth question in this HOTS series. So let's go with the question. Water containing 88.8% oxygen, 88.8% oxygen and 11.2% hydrogen is often used as a fire extinguisher. Can a mixture containing the two gases in the same ratio by mass be used for extinguishing fire? First, understand this question. The understanding is very important. This question is saying water. You know what is a fire extinguisher for extinguishing fires? So it is saying that the water is often used as a fire extinguisher, which has ratio 88.8% oxygen is there. It contains 88.8% oxygen and 11.2% hydrogen. And this water, with this ratio, this water is used as a fire extinguisher. Now it is saying, can a mixture containing the two gases in the same ratio by mass be used for extinguishing fire? अभी क्या कह रहा है? A mixture, मान लो the mixture is X, and this X mixture contains three components. I'm saying three components. उसमें एक हाइड्रोजन, एक ऑक्सीजन और एक कोई भी सब्सटेंस हो. It contains three components. X mixture contains three components: hydrogen, oxygen or कोई भी component you can take. Okay, and it contains 11.8%. The ratio of the mass is same in both the cases. Hydrogen and oxygen, mass ratio will be same, and it is saying, will this mixture will we use this mixture to extinguish fire? It is not possible. Why is it not possible? It is not possible, but why? Actually, in water, oxygen and hydrogen are chemically bonded to each other. They are chemically bonded. They lose their identity, they lose their properties. Hydrogen will lose its property, oxygen will lose its property, and they both will be used for extinguishing fire. Yes? So the property, compound and element properties, both are different. Both have a huge difference. You study chemical change. What happens? The components lose their properties and form a compound which has totally different properties. So they lose their identities, means they lose their properties and help in extinguishing fire. Oxygen is used for combustion, right? But water is used for extinguishing the fire, right? So in X, they are not chemically bonded. They'll retain their properties and they are not chemically bonded actually, and they both will not help together. They won't help together, and this way they'll not be used for extinguishing fire. Water with these both gases will help in extinguishing fire, means they both will work together for extinguishing fire, whereas in the mixture they won't, because they are not chemically bonded. When they don't have a bonding, when they don't know each other, why would they help together for extinguishing the fire? Yes, so these both are totally different from each other, and therefore the answer is no, and the reason I've given you. I hope this is very much clear. This is a very easy question. So let's go on to the next one. The question number 2 says, why does colloids show Tyndall effect? Why does colloidal solution shows Tyndall effect whereas true solution do not? Tyndall effect means scattering of light. It is saying, why does the colloidal solution show Tyndall effect and why does true solution do not? True solution do not, whereas colloidal solution show Tyndall effect. Why is this so? Why true solution is an exception? For this, you just have to understand one thing. For the scattering of light, there should be enough size of the particles for the scattering of light, that is for the Tyndall effect. For the scattering of light, there should be enough size of the particles, and so true solution favors the scattering of light. It has the enough size of the particles so that it can favor the Tyndall effect. Whereas true solution, these particles are very small in nature. They are very, very small and they do not have the enough size which favors the Tyndall effect, and therefore it does not. Tyndall effect. Everything is based upon favorable condition and unfavorable condition. They show the favorable conditions, they do not, and therefore colloidal solutions show the Tyndall effect, whereas true solution do not. It is a very much asked question. The most, I guess it comes in the category of the most asked questions. Okay, now let's go to the last question of today's video. And the question is, why is salt mixed with ice? It is like mixed with ice to form a freezing mixture. Why is only sodium chloride, common salt, used for forming a freezing mixture? First of all, understand what exactly is a freezing mixture. Freezing mixture is it basically, we add impurity to the ice. Freezing mixture is a combination of two or more substance. It is a combination of two or more substance which form impurities. You can say substance as impurities, and they lower the freezing point. What they do is they lower the freezing point. So forming the freezing mixture, we add salt to ice. Why? Because this salt, the common salt, it acts as an impurity and it is very much suitable for lowering the freezing point. Therefore, it is used as for impurity for lowering the freezing point of what? Of water. This is pretty much clear. All the questions are clear. I hope